Assalamu alaikum. Welcome to the medicinal chemistry lecture notes. I am Dr. Akin Naseem. Today we are going to discuss the structure activity relationship of paracetamol. The main structure formula of paracetamol is written over here. You can see the paracetamol structure. So let's discuss about its SAR. The core structure, the base framework. Paracetamol has a phenol ring. Phenol ring I have written over here. The benzene that contain OH group that is substituted with an acetamide group. An acetamide group contains CH3 and the carbonyl carbon with NH2 group. So what is the essentiality of this core structure? The phenol group is critical for the drug activity as it interacts with the enzyme responsible for its effect. Okay. Now next one is the hydroxyl group that is attached in the benzene ring. So the hydroxyl group on the benzene ring is essential for the drug analgesic and antipyretic properties. The modification or removal of this group generally reduces the activity and it contributes to the hydrogen bonding with the active site of the cyclooxygenase enzyme, particularly COX-2. So the role of OH or the role of phenol group is very much important for its analgesic and antipyretic properties of paracetamol. Now let's discuss about the acetamide group. Acetamide group is the C double bond OCH3. I have written over here as well. So the acetamide group stabilizes the molecule and enhances its lipophilicity. So being a lipophilic drug is very much important in order to show their action. So this is very much important, allowing easier passage through the cell membrane. And if we replace the acetamide group with the bulkier or non-amide substituent, the activity will be diminished. Okay. Then we have a benzene ring, or you can say aromatic ring. The benzene ring serves as a platform for substituent like OH and C double bond OCH3. Like it is the platform that help to bind OH group as well as acetamide group. Okay. Substitution of the benzene ring with the larger or the bulky group often reduces its activity by interfering with the enzyme binding. I hope it makes sense. Now let's discuss about the electron distribution. The electronic properties of paracetamol substituents influence its binding to the COX enzyme. The electron donating properties of the hydroxyl group and electron withdrawing nature of the acetamide group create a balance necessary for optimal activity. Okay, there are, as we have discussed, the two main moieties of the paracetamol, that is the hydroxyl group that is attached on the benzene ring and the acetamide group that is attached on the paracetamol benzene ring later on. So electron donating properties of the hydroxyl group or the phenol group and electron withdrawing group of the acetamide group, they both balance the electronic configuration, electronic distribution that is essential for necessary optimal activity. Now let's discuss about the metabolism and the toxicity consideration. The paracetamol undergoes hepatic metabolism primarily through the conjugation. So conjugation is a basically phase 2 reaction in which the glucuronidation and sulfation take place. A minor pathway produces a reactive metabolite, N-acetyl P-benzoquine amine, NAPQI. This is very much important metabolite of the paracetamol. That is detoxified by glutathione in phase 2 reaction. Okay. Structural modification that increase NAPQI production can lead to hepatotoxicity. That is the highlighting the importance of the existing structure. Okay, so you people might have heard that consistent use of the paracetamol may cause hepatotoxicity. So this is where how hepatotoxicity takes place. Now let's discuss about the substituent effect. Para position. The hydroxyl group at the para position of the benzene is important for its activity. Meta or ortho substitution. Moving the hydroxyl group to the meta or ortho position simply reduces the efficacy of the compound. Okay. Additional substituent. Let's discuss about the adding substituent at other position on the benzene often reduces activity due to steric hindrance and altered binding affinity. Okay. Steric hindrance is very much important phenomena. Then we have activity mechanism as per SAR. The paracetamol is believed to inhibit prostaglandin synthesis by targeting COX enzyme, especially in the central nervous system, leading to analgesic and antipyretic effect. The exact mechanism differs from NSAID since paracetamol has weak anti-inflammatory properties attributed to its reduced effect on peripheral COX. Now this is the end of the SAR summary. The phenol group and acetamide moiety are responsible for its biological activity. Substitution at position other than para on the benzene diminishes its activity. Structural modification impacting metabolism and reducing the production of the toxic metabolites are critical for maintaining safety and efficacy. I hope this makes sense. Okay, now let's discuss about the mechanism of action of paracetamol. Acetaminophen or paracetamol, they likely increase the pain threshold by inhibiting the enzyme called cyclooxygenase. They are COX-1 or COX-2, okay, which are involved in producing prostaglandins. And these substances are responsible for the pain. However, it does not act on the COX enzyme in peripheral tissue, so it lacks an anti-inflammatory effect. So, by reading this mechanism, it is clear that paracetamol or acetaminophen is not an anti-inflammatory drug, as they does not inhibit the COX enzyme in the peripheral tissue, so they lack the anti-inflammatory response. However, they inhibit the enzyme cyclooxygenase COX-1 and COX-2 inhibition. Okay, and another mechanism or research that suggests that acetaminophen indirectly blocks the COX enzyme, or they specifically target a variant enzyme called COX-3 enzyme, which is different from COX-1 and COX-2. So its antipyretic or fever reducing effect are due to the action on the brain's heat regulation center, promoting heat loss through sweating and vasodilatation. I hope this makes sense. This is all about the mechanism of action. Now the next important parameters of acetaminophen is the indications. They are primarily used for the pain relief. They contain mild to moderate pain like headache, toothache, or menstrual cramps. Obviously, for the musculoskeletal pain and the post-surgical or the post-injury pain, the acetaminophen or paracetamol is given. Fever reduction, they are used in treating fever associated with infection or illness like common cold or flu. Chronic pain management in combination with other medications, and obviously for the adjunct therapy. Okay, the next step in the medicinal chemistry of the paracetamol is the synthesis of the paracetamol. Here is the written structure of paracetamol that contains benzene ring, NH, C double bond O, CH3 along with the OH or aminophenol group of acetylation. And now, what is the synthesis part? It includes starting material from the phenol, like we have benzene and OH ring. In the presence of the nitration or HNO3H2SO4, they undergoes nitration reaction, and the derivative in this reaction that is formed is known as para-nitrophenol. So NO2 is attached over phenol ring. Okay. Then upon the reduction of this nitrophenol, the next derivative that we get is there is a reduction of the NO2 group and it becomes NH2, so this become para-aminophenol. So the second derivative was para-nitrophenol and this one is the para-aminophenol. Now this para-aminophenol undergoes another reaction with CH3 C double bond OCl or CH3 C double OH, acyl chloride or acetic acid. By removing HCl and CH3COOH, they form NHC double bond OCH3, benzene and OH as well. So this C double bond OCl replaces one hydrogen and attached with the NH group of amino, and this becomes your paracetamol.